Hi guys, my name is X Kuku and I'll be taking you through organic chemistry. Now, when we talk about organic chemistry, this is the study of carbon compounds. But there's something we should take note here. Not every molecule or compound that contains a carbon is classified as an organic compound. A typical example is what we have here, CO2. CO2 is having the carbon that we are talking about, but it is not classified as what an organic compound. We can also talk about the trioxocarbonates. We can talk about this. We also have CO3, 2 minus. They contain the carbon that we are talking about, but they are not classified as organic compounds. So we have to take note of that. Now let's look at carbon itself. Now, using the configuration, we can expand this for us to know how bonds are formed around carbon. So we have carbon here with atomic number of 6. Now, using the electron configuration, we can have 1s2, 2s2, 2px, 2py, 2pz, 1, 1 here, because this have an atomic number of 6. Now, this is what we call a ground state. We have to promote an electron from here and give it to the empty 2pz orbital. So that will give us 1s2, 2s2, 2s1, 2px1, 2py1, 2pz1. Now, this is what we call excited state. Now, looking at what we have here, we have 1, 2, 3, 4 unpaired electrons. That is 1 here, 2, 3, 4. Meaning that carbon is able to bond with 4 different elements. So as we progress, we understand why it is so. We can also write this. Now, using the configuration, we can also have the first shell taking 2, second taking 4. This is telling us that carbon is having 4 valence electrons. Now let's look at some of the properties or the abilities of carbon. One, we can talk about catenation. That is, they have the ability to catenate. Now, when we talk about catenate, it simply means that they can form long chains. A typical example is what I have here. That is carbon joining carbon, joining carbon, joining carbon. That is giving us a long chain. But we have to look at the nature of carbon. Please take note of this. Because carbon is able to form 4 different bonds around it, we can pick carbon here, 1, 2, 3, and this is giving us the valence electrons. Now with this one, carbon here should be able to give you 4 bars. When I say 4 bars, it means the number of atoms that can be bonded to a carbon. We can also have this in this format, and that is also giving you the 4. That is a double bond being formed. We can also have it in this format, 1, 2, 3, 4. So that is the nature of what the carbon. The number there shouldn't be more than 4 or less than 4. So please take note of that. So the first one, we said that they can catenate, that is form long chains. The second one that we can also talk about is the formation of straight chains, branch chains, and ring structures. So if you want to talk about the straight chains, then we can have carbon joining another carbon here, joining another carbon, joining another carbon. Now we have 1, 1, 1, 1, and that is giving us the carbons which are being joined. And we said that each carbon should take a maximum of what? 4 bars, not less than that, not more than that. So we can bring the remaining bonds. So we have 1, 2, 3, 4. Let's assume that it is being attached to hydrogen atom. So we can have each, each. So 1 here, 1. Please take note, don't let it exceed the number. So that is giving us a straight chain. Now, with this straight chain, we can also form a branching from it. That is, we can also insert another carbon here to give us what we call a branching. So 1, 2, 3, 4. Now, if I put another carbon here, I am forming what we call a branch chain. We can also form ring structures. That is, carbon here. Let me use a cyclic one. So if you have something like this in a form of hexagon, it simply means that you have carbons coming together to give you this structure. So carbon, 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 carbon. And this is what we call the ring structures. So carbon can form a straight chain, it can also form a branch chain, and they can also form the ring structures. Then the third one that we want to talk about is the formation of single, double, and triple bond in carbon. We are still on our point that carbon should form 4 different bonds. So we have carbon here being joined by a single bond here, single bond. Now this is what we call single bonds. It is being joined by another carbon. So that is a single bond. Now the second one that we can talk about is a double bond. So if you have 2 lines in here, in between the carbon, that is telling you that you have formed a double bond. The last one I want to talk about is the triple bond formation. So we have carbon joining this carbon, and that is giving us the triple bond. So we are also saying that they can form single bonds, triple bonds, that is carbon to carbon chains. Now the last but not the least is the formation of what we call isomers. Now isomers are different compounds that have the same molecular formula, but they have different ways, different structural formula. So if we pick certain organic compounds, we can form different compounds with that. Now, a typical example is what we have here, C4H10. Now, we want to form isomers with this. We are saying that it should be the same molecular formula, but different structures. How many carbons do we have over here? 4. 10 hydrogen atoms. We want to form bonds with this. So, first of all, you go with a carbon, joining carbon, joining carbon, joining carbon. We have our 4. The next thing is we set our hydrogen atoms. We shouldn't exceed the 10 and it shouldn't be less than what 10. So we have hydrogen atoms being formed. You can cross check, count, and see whether we have exceeded our number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the first one that we are having. It is 4 carbons that we are dealing with. The next step is take one of the carbons away, keep that in your bag, if you can do that for me. So after taking one away, we are having 1, 2, 3. Bring the carbon that you took back, but send it to the center. So that is what carbon here. Now the next thing to do is for you to bring the hydrogen atoms. So we have H, 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 H. Once again, we shouldn't exceed the 4. So 1, 2, 3, 4. So that is okay. H, 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 H here. Now, from what we have here, we have the same number of carbons, 1, 2, 3, 4. The same number of hydrogen atoms in this. But we could see that we have different what structures. Now, when we get to the name, we will name these organic compounds. All right, now the last thing that we want to talk about is the formation of four different bonds. That is what we call tetravalency. That is, they're able to form four bonds around it, as we talked about earlier on. So we can just take a look at this one. All right. Now we want to look at classification of organic compounds. The first one that we want to talk about is aliphatic compounds. Now, when we talk about aliphatic compounds, these are compounds which have carbons being arranged in open chains. We can talk about double bonds, we can talk about single bonds, we can also talk about triple bonds in there. So when we have an alkene, they have the single bond. Alkenes have the double bond. Alkynes, they have triple bonds. So they are classified as aliphatic compounds. A typical example is what we have here. So carbon joining carbon joining carbon. This is giving us an open chain. We can also talk about this one giving us an open chain. We can also have the one with a triple bond, and that is what we call aliphatic compounds. They have open chains. The second one that we want to talk about is the alicyclic compounds. Now, when we talk about alicyclic compounds, they contain close ring of what? Atoms. And there's something that you should know. This ring may be single or double. A typical example, we can have this ring structure here. This is an alicyclic compound. I can also insert a double bond in this, and that is giving me a ring cyclic compound. The third one is also called heterocyclic compounds, and these are compounds which contain rings of atoms, which includes atoms other than carbon. So we can have all the carbons forming the structure, but there should be another element in there. A typical example is what we have here. So if I put S here, this is carbon, that is carbon, that is carbon, that is carbon, but this is a different what element, and that is what we call heterocyclic compounds. We also have the last one to be aromatic compounds. In fact, they form rings of carbons with pi electrons, or what we say the localized electrons around the structure, meaning that they have double bonds in them. A typical example, which is very, very common, using this benzene ring, we can have this compound here, which is an aromatic compound. Now, if I draw another benzene ring, that is also giving me a naphthalene. So looking at this, we have what we call the pi bonds in there, and that is giving us what we call aromatic compounds. All right, now we want to consider hydrocarbons. When we talk about hydrocarbons, these are organic compounds that contain carbon and hydrogen only. Please take note of that. It is carbon and hydrogen only. Now, looking at the hydrocarbons, we can have saturated hydrocarbons, we can also have unsaturated hydrocarbons. But when you take aromatic hydrocarbons, there is a general name given to those compounds, and that is what we call arenes. So aromatic hydrocarbons are called arenes. Considering the types of hydrocarbons that we have, that is saturated hydrocarbon and unsaturated, we can get examples under that. That is alkanes, alkenes, and alkynes. How do we classify them under each of the types? So let's take the first one, which is saturated hydrocarbons. Now, these are hydrocarbons that contain carbon chain, that is single bonds in between the carbon. We can talk about alkenes being saturated because they are bonded by single bonds. Then the second one, is what we call the unsaturated hydrocarbons. Unsaturated hydrocarbons. So these are hydrocarbons that contain double bonds in between the carbon. And we can talk about alkenes, alkynes. Alkenes, they contain double bonds. Alkynes contain triple bonds. So in unsaturated hydrocarbons, we can talk about double bonds being formed. We can also talk about triple bonds in being formed in the molecule. So we now know that we have what we call aliphatic hydrocarbons, that is open chains, and we can talk about saturated and unsaturated hydrocarbons. Under saturated hydrocarbons, we have alkenes. Later, I will look at that. Then we also have alkenes and alkynes under unsaturated hydrocarbons. That is, they have double bonds and what? Triple bonds. Now, let's look at what we call the general formula for all the organic compounds that you are going to study. We will talk about alkenes, alkynes, alkanol, alcohol, alkanoic acid, esters, etc. So now let's look at their general formulas. Because before you can identify that a molecule, a carbon containing compound is an alkane, you need to know the general formula. So now let's take a look at that. So the first one that we can talk about is that of alkanes. Now, alkanes here, they have general formula CnH2n plus 2, where N is the number of carbon atoms. We'll try one. We also have alkenes, which is CnH2n. Alkynes that contain triple bonds, CnH2n minus 2. We can also talk about alkanol or alcohol. The general formula is CnH2n plus 1 OH. We can talk about carboxylic acid or alkanoic acids. Alkanoic acids. And that also give us CnH2n plus 1 COOH. We also have what we call ethers. Now, ethers, they have ROR. ROR. Now, this R here stands for what we call an alkyl substituent. When we talk about alkyl substituent, it can be a carbon chain joining this O here, another carbon chain joining this O here. Now, when we get to the naming, we will look at those alkyl substituents. We can also talk about esters. Esters, that is a combination of alkanoic acids and alcohol. That gives us what we call the ester. And that is also having the general formula CnH2n plus 1 COOR. Once again, I said that R there is an alkyl substituent. So we'll look at that as we progress. Now we know the general formula. We want to apply the general formula to determine whether a molecule is an alkene, alkyne, or alcohol. How do we do that? We are saying that N here stands for the number of carbons. So if N is equal to 3, we want to pick all the general formulas and try with the number 3. So the first one, we talked about CnH2n plus 2, which is an alkane formula. So N is equal to 3. Then that will give us C3H2 times 3 here plus 2. And that will give us C3H8. Now let's pick the second formula, CnH2n. N equals 3, that is C3, H 2 times 3 here. So that will give us C3, 2, 3, 6, H 6 here. So can you see the difference? This is C3, H8. That is giving us C3, H6. We can also pick the other formula, which is Cn H2n minus 2. Inserting 3, we are going to get C3 H2 times 3 here minus 2. And that will give us C3 H4. So we can use the formula to know the difference between alkanes, and alkynes. But if it is an alcohol, then that will give us Cn H2n plus 1 here, OH. So inserting the 3, that will give us C3H2 times 3 here plus 1 OH. So we are going to get C3H7OH. And the presence of this OH is telling us that it is an alcohol. You can try with the other ones to determine the organic compound, whether it is alkanoic acid, ether, or whatever it is. Now we want to look at some examples whereby we can pick the number from the molecule, then determine whether it is an alkane, or alkyne. So let's look at that. All right, so now using N equals 3 and getting C3H8, C3H6, C3H4, C3H7OH, we can just look at the structural formula. That is when we open the chains in the carbon. So the first one we had C3H8. How many carbons do we have here? We have 3. So we are going to expand this. Take note, carbon always join carbon. So we have carbon joining carbon, joining carbon. This is the format that we want to use. Now, because we know that the formula, it is an alkane, it should contain single bonds. So what we have to do is bring the hydrogen atoms around the carbon. Once again, it shouldn't exceed 4, and that shouldn't be less than 4. So let's count 1, 2, 3, 4. 1, 2, 3, 4. Here we have only 1 attached to the carbon here. So we will bring the remaining 3, and that will give us C3H8. We can also pick the other one, which is C3H6. We know that is for alkenes, and alkenes should contain double bonds. So we have the same number of carbon atoms. Because alkenes contain bond, we can insert the double bond here, or we can even bring it here. It is the same thing. Now, when you do it this way, you are supposed to bring the hydrogen atoms. Bear in mind, the number of carbons should correspond to whatever you have here, and the number of hydrogen atoms that you have should also correspond to what you have here. So we have 1, 2, 3, 4 bars as we talked about. Now over here, let's count 1, 2, 3. So we can bring 1 hydrogen here, or we can bring it down. It is the same thing. So H. But mistakenly, if I bring another hydrogen here, let's count 1, 2, 3, 4, 5. That makes this thing incorrect. So we have to take this one from there. Then we move to the last carbon. Let's count 1, 2. How many more do we need? We need what? 2. So we can bring the 2 hydrogen atoms. Now let's count 1, 2, 3, 4, 5, 6. And that is complete. We can also pick the other one, C3H4. with the same number of carbons, 3. But bear in mind that these are under alkynes, and alkynes have a triple bond. So we know that the carbon to carbon change will give us a triple bond. We can insert the triple bond here, then arrange the hydrogen atoms around it. So we have here to be complete. Here it is already complete because we have 1, 2, 3, 4. So that is okay. There's no need bringing another hydrogen atom here.
Then over here we can bring 1 because we do have 3 here, with the 1 giving us a 4. The last one that we can draw is that of the alcohol. 1, 2, 3. We can join the OH molecule. Take note, it is carbon joining OH, not carbon, hydrogen, O. Take note of this. And this is giving you the alcohol or the alkanol. Now let's make our remaining hydrogen atoms around the carbon. So we still have to bear in mind the number which is there. When we finish, we will count. If it exceeds the number, and it is here wrong. So let's count. 1, 2, 3, 4, 5, 6, 7. With the 1 here, and that will give us 8. So oxygen is 1. So for C, 3, 8, 7, OH. That is what we are going to get. So based on the molecules, we can draw what we call a structural formula. Now the next thing I want to talk about is when you are given the compounds for you to determine whether it is going to be an alkane, alkene, or alkyne. So let's look at some few examples. Alright, so we can pick C5H10. We want to determine whether it is going to be an alkane with a single bond, double bond, or triple bond. So first of all, we are dependent on N. N is the number of carbons. It is not the number of hydrogen atoms. So if N is equal to 5, then what can we deduce from this? We can insert this in the first formula and see whether it will work. So we are inserting 5. C5 here, 2 times 5 plus 2. See, that is not working because we're going to get C5H12. So this formula here cannot be used. Now let's try with the second formula. CnA2n. That is C5, 2 times 5. That will give us 10. Meaning that the C5H10 compound here is an alkene which should contain a double bond. Please take note of that. Now let's try the other one, which is C6H10. C6H10. Okay. So we can also have N to be equal to 6. Now let's try. First formula, CnA2n plus 2. Okay, so we have C6, 2 times 6 plus 2, and that will give us what? 14. So this formula is out. Now let's move to the next one. We can have CnH2n. So we have C6, 2 times 6, that is 12. This is also incorrect. That is incorrect. That is also not correct. We can also try with the last one, which is CnA2n minus 2. Now let's see if this one will work out. We have C6H2, 6 here, minus 2. C6, that is 2 times 6, 12, minus 2, that is 10. So we can also see that this one is corresponding with what we have here. So it tells you that this is an alkyne and we should have a triple bond. So whenever you are giving examples on this for you to determine whether there is a double bond, triple bond, or single bond, you can easily apply the formula and you are good to go.